In this tutorial, we're going to go through a natural language programming, or NLP, pipeline. We're going to attain text from scraping data from a website. We're then going to create a word cloud. We're going to perform sentiment analysis on our corpus, or all the content. We're then going to perform topic modeling, where we cluster our data. These are very commonly used tasks in text analysis. We're going to be using Python in Google Colab. I do have a tutorial if you're not familiar with Python or Google Colab for that matter. I'm making quite a few assumptions because every time we run NLP, we need to do it slightly differently. There's no one way of doing it, but this will give you an overview of the steps and what you need to do, and then you can configure the steps slightly if you need to. So let's get on to scraping the data. Now, I'm just assuming for this example, this tutorial, that we're doing some research on health information. There are many websites with health information, and I'm going to use from the Harvard, or data from the Harvard Health blog. They have many different articles, 5 timeless habits for better health, and so on. So we'll scrape that data, we'll get that data from the website automatically and then analyze that data. I just know from my experience with websites, with HTML, CSS, etc., that most websites have what's called a sitemap.xml. So I'm going to go to that, but I notice that the content is at a sitemap called sitemap-content.xml. So let me just go to that to illustrate what's there. So it's pretty big, this sitemap, and it'll load again in a second. But once it loads up, what you'll notice is that there are various different ways these URLs are structured. I just know from going to the website and then going into one of the articles I want to scrape, for example, is that they start with health.harvard.edu/blog. So what I'm looking for in that, you can see it's too big anyway to load that sitemap. What I'm looking for in that sitemap is all URLs that start with blog. And that's what I will scrape. So what we're going to do is we're going to use Beautiful Soup, which is a Python package. It is really good for going to websites and automating the process of analyzing the sitemap, attaining the different URLs, and then going and scraping the content. What I'll do is we'll take a short break while my computer sorts itself out from this very large sitemap, and then we'll start scraping the data. We're in the Colab notebook for the code that we're going to run for our NLP. I will share the URL for this notebook in the description section of this video so that you can get a copy of it. We'll be using Beautiful Soup to scrape that data from the Harvard website. Make sure you've got permission to use the data from websites or scrape that data from the website. Let's go through what we're looking at here. Just going down the page a little bit, we're going to extract certain things, extract the date, extract the title, extract the content, but going down, okay, so we are telling Beautiful Soup in this case, or Python in this case, to go to sitemap-content.xml. However, we wanted to look for only URLs that start with health.harvard.edu/blog. Then we specify where the schema are for the sitemap file. We're specifying where to save the data. So save all the content. Beautiful Soup will save all that content to harvardhealth.csv. And just going down, various ways we're going to save that data. So we're looking for a selector called time span. We're going to save the date, format, the title, and so on. Now, we need to know a little bit about HTML and CSS and selectors and so on. For example, looking at the Harvard Health website, if we're going to download these blog posts and we want the content, We don't necessarily want everything that's here, such as the sharing buttons and so on, because that can skew our NLP process. Because if there's continuously the word Facebook, for example, but it actually doesn't have any meaning for our data in this case. So we can specify in Beautiful Soup to attain certain data from the website, from the different pages, but not others. So I'm just going to alternate click and click inspect. And just by looking at this, I've noticed that, where are we here? Where are we? I've just noticed that the content is underneath something with the classes of, for example, mx-auto, and I would have to do a little bit of work on determining that that's true. I then know, for example, that, let's just inspect that the title is with an H1, so I can put the title into a separate field. However, in this case, I'm also, and it's in the code, I'm also excluding various selectors. So, for example, I'm not going to keep data where the class is bg-grade-50 because this doesn't have any meaning for my research purposes, for example. Again, you need to iterate a lot in this process and you'll learn as you do it. I will therefore run this. It'll scrape that data as we've seen, and it'll save it to a file locally in Colab, which we can then use for our word cloud and so on. So I'm going to click run, and what we'll see in just a second is we'll see it'll start running. So here we go. So it fetched the sitemap. It found 13,000 odd total URLs, but it found 2,745 with blog in the URL as we wanted, and it started to scrape them. Now, it'll take quite a while, 10-15 minutes probably, to scrape 2,745 blog posts. So we'll come back once that's finished running. The script has now finished running, so let's look at the results. We'll scroll down the Colab notebook a little, and we can see all content saved to harvardhealth.csv. So the content's now been scraped and saved to a file. If we click Files and double click that file, we'll be able to view what's in that file. Now, it's a pretty big file, so it will take a few seconds to open. What we can see here is we have 4 columns: the URL, date, title, and content. Because words have meaning, and that's why we're doing natural language programming or NLP, we would want to combine or concatenate the title and content fields together. So let's do that. I'll just close this window and close this little window as well. So we'll do some data cleaning to start off. So first we're going to load up that file we've created, harvardhealth.csv. By the way, the code I'm using here is very modularized, so it's not as efficient as it could be. But for demonstration purposes, it's good the way it is. Then what we're going to do is we're going to concatenate the title and content separated by a space into a field called title content. We're going to convert the date field into date time format, and we then are going to view the number of articles per year in a chart. So let's just run that. It won't take too long to run, and there we go. There's our chart. So what we can see a few strange things here. We can see that in 2020, for example, 396 articles were published, which is way more than other years. Now, we would investigate perhaps why that happened. In this case, we know that that's when COVID kind of started. So that's probably what that was. Another thing here is in late 1960s, there were 4 articles published. Now, that probably isn't true because I don't believe we had blogs in the late 1960s. We would look at that and we would obviously correct it if needed or eliminate those we don't need. Then we're just looking at the head again, and now we can see we have a new year column and a title content column. Of course, the year column was created so that we could show this chart by year, the number of articles per year. Now, in NLP, Removing stop words is very important. Stop words are those words that don't have meaning. So for our analysis, because words matter, words like the, and so on don't add to our understanding of the content. Therefore, we want to remove them. In Python, a very popular package is NLTK, Natural Language Toolkit package, and they have stop words included in NLTK, which we would often remove those stop words before we continue processing. But let's just look at those stop words. So I'll just run that, and we can see the English stop words are about, above, after, again, against, and it goes on and on and on. To generate our word cloud, we're going to do various cleaning. We're going to use the word cloud library or package in Python. Sorry. So we're first going to load up our file and do various things. Now, I've also added here some custom stop words that you can add if you want to. I've included the words may, keep, need, and so on, but you can just add to them here. Then we're doing various other things, getting rid of empty results, lemmatizing, which is returning or reducing a word to its base form. So the word like running or runs will be reduced to run, so that we can tell how often the word run is used, even if it's used in different forms. So various different things, and stop words removed and so on. So let's run that. So what we're expecting to happen is that once this is finished running, we'll see a word cloud with the words most frequently used. This will take a while to run, so what we'll do is we'll take a break and come back to it. The word cloud has now been generated. We can see here words like time, patient, child, people, treatment, cancer, prostate, etc. are highly used, or blood pressure and so on, are words or terms that are used very often within the corpus. Of course, we could go back and run this again and, for example, add the letter S and so on, so it doesn't show that on our word cloud. Oh, and if we want to include images, just a tip, if you want to include images in your research and so on, you can just alternate click and click Save Image As to save any of these images. Then we're going to get on to sentiment analysis. Sentiment analysis tells us how positive or negative or neutral the wording is in that article. We will run this. This will take a few minutes to run, and then we'll come back. What it's going to do, just as we go through here, what it's going to do is it's going to determine the sentiment for each row, each article in the corpus. Then it'll show us a plot per year of how positive or sentiment on average the different posts were. But let's run this. We'll just double check that it's running down below. Let's just go down. So downloading Veda from NLTK, download complete, calculating sentiment scores. It will carry on with that, and then we'll get back to it. The sentiment analysis script has now finished running. So first of all, we see the head here. We kind of see what's going on, and we can see a sentiment score has been given to each article. So a negative means negative, negative sentiment, sorry. A positive would be positive sentiment. Let's go down a little bit, and here it's the average per year. So in 2010, it was slightly positive. We had 1 year that was negative, which was 2014. So it would be worth maybe looking at, why is that different? Why was there negative? Why were most of the articles negative there? It could have just been whoever was writing the articles and so on. It really could be anything. And just a chart viewing the average sentiment over time. And we can see how it goes up and down a little bit. And again, we can see that the only negative was in 2014. Now, the highest sentiment, or the most positive sentiment, was in 2022 and 2024. Let's carry on. We're going to now get on to topic modeling, or what's also termed NLP clustering. Because we don't know the subjects, the general subjects in our corpus. So we can use Latent Dirichlet Allocation, which is often used in research and academia. We can use it to find which topics, or how many clusters there are, how many topics, and can assign each article in the corpus to one or more topics. So we will run that. Now this is pretty slow, so we'll go away and come back. We're going to use Gensim and scikit-learn, two very widely used Python libraries to do that. We're first going to clean the content, just make sure that it's all clean. What we're going to do, which is, I've automated the process here, slightly different. So with Latent Dirichlet Allocation, we have to tell it how many topics we want to divide the content into, or determine is in the content, as it were, in all the text. But the problem is we don't know how many. So we're going to use something called coherence scores, or determine automatically, or we're going to determine the coherence scores of the number of topics. So it looks and says, okay, so if, for example, like here, min topics 5, if I assigned 5 topics, or divided all this content into 5 topics, what is the coherence score? And we'll look for the highest coherence score. We're going to go up to 12, but generally it'll go higher, but it is pretty slow, so I've put it in 12. And it will automatically then assign the number of topics to the LDA, the Latent Dirichlet Allocation model, and then divide up the content into that many clusters or topics. So we'll click run on this, and we will come back when it's finished running, which could take quite a while, to be absolutely honest, but we'll see you then. The script is now running, so let's see how we went. First of all, determining the number of topics, the ideal number of topics in the content. Where the coherence score is higher means that that's more likely to be the correct number of topics. Now, you will need to do a visual overview of it to determine the correct number. But in here, the number of topics being 11 had the highest coherence score of 0.54. To be absolutely honest, I would run this again, going to an increasing number of topics, just to check if perhaps the optimal number of topics is higher than 11. 11 isn't a large number of topics. Normally it's slightly lower, to be honest. You can change the testing for the number of topics that you want to test for in this section here. So where I've got a min number of topics, that's 5 and 12, so that would be up to 11 topics I test again. I would increase that 12 upward. And then we see it on the chart. So yes, 11 had the highest coherence score. Then the LDA model was trained, assuming that 11 was the optimal number of clusters in the content. And we can see that it's been saved to our data, the topic number that each article belongs to. So this one belongs most likely to topic 6. This one most likely topic 5, or has a high, that's the content is mainly in that topic. Then we've looked at, or we've printed out here, each of the topics, so 0 to 10, 11 topics, and the words that mostly appear for each topic. So for topic 0, BPH, urinary, palmetto, bladder, urine are the most frequently occurring words, or most likely to be occurring in that cluster, whereas in topic 10, food, diet, healthy, eating, oil, etc. are most likely to appear. And then we can see for each of these articles, for example, which topic they're in. This one's in number 6, for example, which is study, risk, blood, disease, heart, and so on. So that's how we run a typical pipeline when we're researching, trying to find the words that have meaning in our corpus. Please like this video and please share it too. And thanks for joining me.